All right, so today we're going to talk a little bit about ecology. So we're going to talk about the different factors in an ecosystem, which are abiotic and biotic factors, and then talk about more of the abiotic factor side of an ecosystem by discussing climate and weather, and that will then lead us into talking about the greenhouse effect and climate change. And that is also related then to our hydrologic cycle and our carbon cycle. And then we'll continue on with the rest of our nutrient cycles for an ecosystem. So let's kind of review our levels of organization. We've kind of started off the semester talking about atoms and then cells and a single-celled organism such as a prokaryotic cell. And then from there, we moved up to eukaryotic organisms, which are multicellular, and they can have a lot of different tissues and organs that are part of their bodies. And then we more recently moved on to talking about populations, where all members of the population were of the same species. So they're all the same if they belong to a population. So they're all the same species. From there, we did not really talk about communities, but a community would be all the organisms that inhabit a particular area, so kind of an assemblage of different species. And then we move up to the level of an ecosystem, where we're not only talking about the organisms and how they interact with each other, but also we're including the physical environment along with the organism. So we're looking at the living and the non-living components of that ecosystem. Okay. And we can use the terms biotic and abiotic to describe these two components of an ecosystem. The biotic component would be, let's say, the plants, the animals, the bacteria, fungi. It's even the leaves that fall off the trees. It's the waste material that is produced by all these living organisms. And also when they die, it's their bodies. So even though they may no longer be alive, it's still considered a biotic component. And the abiotic component, or the non-biological components of an ecosystem, would be such things as the sun, the amount of sunlight the ecosystem receives, the nutrients such as nitrogen and phosphorus, how much oxygen's around, the air itself, the soil, the water, the climate, the wind, how much, if they're aquatic, how much water turbulence there is, the salinity of the water. All these would be considered abiotic components. All right, so they're kind of the non-living components. So we're going to focus on the abiotic factors. So we mentioned climate in there as an abiotic factor. So climate describes the long-term patterns and averages of weather for a particular region. And this is usually measured over decades when we're talking about climate. So this is very different than when we're discussing weather. So weather refers to short-term, kind of day-to-day conditions. So it's the temperature, like what's the temperature today? Is it raining outside? How humid is it? Is it windy? So it's the day-to-day conditions. It's kind of what you experience when you step outside each day. So while both weather and climate refer to atmospheric conditions, they differ in the time scale. So we hear a lot in the news about climate. So let me change my slide here. How is this different from global warming, or let's say the greenhouse effect? And are they even connected? So we hear about climate change, right? So kind of what's our difference between climate change, global warming, and the greenhouse effect? So climate change is the long-term change in the average weather patterns of the Earth's local, it could be its regional, or it could be its global climate. And the main driver of these changes in our climate are primarily due to the burning of fossil fuels. So that's the burning of oil or coal or natural gas, and all of that started during the Industrial Revolution. And burning of fossil fuels emits greenhouse gases. So these gases, what they do is they help to trap heat in our atmosphere. So the greenhouse gases are such things as water vapor, which we have very little control over the water vapor that's on our Earth, all right, and we contribute very little to that. Carbon dioxide, which occurs in extremely small quantities in our atmosphere, which is why our usage has caused such a big impact, right? Because it's such small amounts, and then we start producing a lot more. Ozone's also a greenhouse gas. Methane's a greenhouse gas. There's what's called nitrous oxide is a greenhouse gas. And then you may have heard of chlorofluorocarbons or CFCs that were in like refrigerants. They were greenhouse gases as well. So, let me get back to my slide there. Here we have an image from your book that is showing kind of what happens with the greenhouse gases. So the sun's radiation basically strikes the surface of the earth, and some of that radiation is absorbed and some of it's reflected back out into space. And what greenhouse gases do is they absorb that infrared radiation, and they in the form of heat, right? So the heat is being reflected back off the earth, and they absorb that radiation, and some of it is reflected back by those greenhouse gases. So this helps to warm the planet, and that's exactly what we need. So the greenhouse effect basically keeps our planet a very nice temperature. And if this did not occur, our planet would be extremely cold. It would be about negative 18 degrees centigrade. So we need the greenhouse effect, right? The greenhouse effect has been around for a long period of time, and it's what keeps our planet a nice temperature. It's only when we have started increasing these greenhouse gases that we are now contributing to climate change. All right, so climate change is caused by more greenhouse gases that are causing the Earth to increase in temperature. But this is not the only change that we're seeing. There are weather patterns that are shifting, which are causing some areas to receive more rainfall than usual, and other areas have had dramatic increases in precipitation. Storms are becoming much more intense. So when we see hurricanes, they tend to be higher categories. Glaciers are melting, and we see sea level is rising. So all these changes are referred to as climate change. So on this slide, we're kind of comparing global warming and climate change. So as it says, global warming is a significant increase in the average surface temperature of the Earth over decades or more. And then climate change, I'm sorry, that climate change should not be a bullet under global warming. It should be kind of its own bullet there. It should be moved over. And climate change refers to not just global warming, but a lot of the changes that are happening that we're seeing because of this increase in temperature. Now, we mentioned water vapor is a greenhouse gas. So let's look at what we call the hydrologic cycle. This cycle describes kind of the continuous movement of water through the Earth's atmosphere from the air to the surface of the earth and even underground. So it begins with evaporation. And this is where heat from the sun turns liquid water from the oceans and lakes and rivers into water vapor. And plants also release water vapor through a process that's called transpiration. So they can lose water across the surface of their leaves, which is why they have stomata, which help to close off the openings in their leaves so that they don't lose as much water. So we have evaporative loss coming from bodies of water, and then we have transpiration coming from the plants themselves. Then, as water vapor starts to cool, as it rises up into the air, it starts to become cooler and it forms clouds. And it forms clouds through the process of condensation. So when clouds become saturated with all these water droplets, then the water falls back to earth as either precipitation, which can be either rain, sleet, snow, or hail. And some of the water flows over the land. Once it precipitates down, it might flow over the land instead of soaking in, and it becomes what we call runoff, and that runoff returns to the bodies of water, while other soaks into the ground and becomes part of the groundwater. But either way, groundwater also kind of flows back to the oceans and to other bodies of water nearby, and the cycle begins again. So in the image here, you can see transpiration from plants, evaporation from the bodies of water. So all that liquid water is being converted into the gas. It cools as it gets up into the air. So that is our condensation. And then we've got precipitation happening where it's raining down onto the land. Some of that water is running off into the little lake there. So instead of soaking in, it's running downhill into the lake. Others will be soaked into the soil and maybe taken up by plants, by their root systems. Other water will completely move down into the underground system and become part of the groundwater, which then still runs down into the ocean.